Okay, today we are going to see is about domain 1. Just a second, let me check. Yeah, domain 1, task D. Okay, let me show you here. This is domain 1 and task D, the last one, last chapter, which is setting filter sensitivity and the gain. Now let's go and check it out. Now here it's like by the end of the module student will be able to. So what I'm trying to tell you, like after we complete this study, what you're going to learn. That's the curriculum thing. So let me check. After we complete this thing, you will learn about identifying the functions of the high and low frequency filter. I think you may be thinking about what is filters. And you will also learn about explain how sensitivity and gain affect signal display. You'll learn about sensitivity, you'll learn about gain. And after this, you will learn about recognize standard settings for various PSG channels. And you will learn about troubleshoot common waveform display issuing using setting adjustment. And you will learn about apply appropriate settings in the simulated or real PSG software environment. Now on this one, before I start the the course, I just wanted to tell you, like, what is this, what is we are talking about, okay? Because unless you will know, you will not understand what's going on and what is this for, what kind of thing we are studying. So I'm gonna draw something and show you, like let's check this one here. Okay, now because we know that, like, the different types of waves, right? Like let's say this is C3 M2 and this is F3 M2 and this is C4 M1. As you see here, the negative, like the odd number channels, are referenced by the M1 and M2. So odd number 3, 1, 3, like 3 and 3 are always referenced by M2 and 4 always referenced by M1, because this has to be referenced by opposite reference channels. Now let's see on this thing, because you need to understand I'm talking about the waves, okay? Different waves, and that wave is like what types of wave we have: alpha, beta, theta, delta, spindles, K complex, like those, right? And now let's think about when we connect our leads over here on the head. So normally the head gives us like this kind of channel, look, like this kind of channel. Okay, this kind of channel. This is what our, when we connect the lead to our head and run the study, this is what it gives. I mean, it can even give like big one, like let's say it can even give, if this is the one channel, it can give like this, this is what you will get. Now with this wave, can you tell what is a spindle, what is alpha, beta, theta? Can you tell with this wave? No, right? Because this is just because this electric like electric power, like electric signals, create this kind of thing. And we cannot say what is spindle, what is theta, what is delta. So what do we? Okay, since you're a pastor, I'll give you an example, different way. All right. Okay. I don't know. I'm recording this one too, so, but it's still like I will give you, like, let's say this is church. You will understand this very well. Okay. Church. And your church has 3 years old, the least one, or 6 months. You have like children of 6 months. Okay. And you have another old people, 81 years. All right. Now what you're trying to do, a Bible study. You wanted to say this one is adult Bible study. Okay. You want to do adult Bible study. So can you keep people here? Can you invite people with 6 months?
No.
No, right? Can you invite 81 years old?
Yes.
Okay. Do you think 81 years old is adult, or they're the senior, right?
Yes. Seniors.
Okay. So maybe you don't want adult group. Like, okay, let me even make it clear. Instead of adult, you will do youth Bible study. You want to set up a youth Bible study. So what age people you want here? You tell me.
Like 16 to 20.
16 to?
22.
Okay. All right, very good. So this is the door. So what you're going to tell them, the least one or youngest one, you make a criteria, right? You say youngest one should be 16 and oldest one should be what, 22? Okay, 22 years. So this is your criteria. This is your criteria. And you don't want to, if you don't fix the criteria, then what happens? Everyone will come. 6 months, 81 years, 21, 60, everybody come over there, and it becomes like a church. It becomes like a church. And this is not a church. This is Bible study group. So you want 16 to 22. And then you will be happy. Okay? Because you filtered the number of people and that age people, and you will get certain number. Let's say total church population is like 500, but out of 500 you got only like 30 people. That's what you want, right? You don't want like 600 people, 500 people over there. So now this is called, that's why the filter, because I didn't ask you, but you told me what group you want. You told me minimum, maximum, youngest, oldest. Now here, let's talk about this. This is the wave. This is the wave that our brain makes when we connect without filter. Without filter, all kind of waves come over there. But you don't need those waves. With the help of this wave, you can do nothing. You need a type of wave where you can say that I can see alpha. That means you may say I can see 16 years old. And beta, I can see like 22 years old. I don't want like 80 years old. Same way, you don't want 60 Hz wave here. So that's the frequency setting, okay? The frequency Hz, you need to set up filter. What kind of what Hz of setting you want. Like let's say if you tell if you filter here lower frequency filter, that's called lower frequency filter, and higher frequency filter. Okay, so you need to filter the amount of wave you need. Okay, let's talk about what is the Hz or frequency of delta. What is the frequency of delta? That is, delta is less than 4, right? Delta wave is less than 4. Yeah, you need to understand. You need to recite that. And what is theta? Theta wave is, frequency of theta wave is 4 to 7. Okay? Frequency of theta is 4 to 7. And frequency of a spindle. What is a spindle? Frequency of a spindle is 11 to 16, right? And what is the alpha? Frequency of alpha, that is 8 to 13. Now these are the frequency. And then beta waves, you need beta waves, which is greater than 14, or it says greater than 14, or the high frequency filter. Now and these are the frequency setting, but this setting has frequency of 300 Hz, 600 Hz, never know, 1000 Hz. And do you need that? No. 60 Hz, if you get 60 Hz, 60 Hz becomes like this. 60 Hz becomes like a straight line. So we don't need those. So what we do, we filter it out. Okay, we filter it. Now let me show you what is a filter. So what kind of filter you want? Now check it out. Look, there's a different kind of like let's say frequency filter setting. Lower frequency filter is like, typically the settings are for EEG. You know what is EEG, right?
Yes.
So EEG waves like C3, C4, F3, F4, those are the EEGs. O1, O2. And EOG for the eyes, electrooculogram. And this is EMG, that's like chin and leg lids. So these are the minimum settings is like lower frequency settings should be 0.3 Hz. For EEG, for EOG 0.1 Hz, for EMG 10 Hz. Okay. So at least you understand like what is this? You understand like what we are talking about, right? Now you know it is like if we don't filter it, then it gives like all the dark waves. We can't do nothing. We can't do nothing. Like we cannot find all this alpha, beta, theta. We cannot see any of these waves. So what we need to do, we have to filter. And we don't want the whole church. We want the only 16 to 22 Bible study groups. Same way for the EEG. All right, now I'm going to tell you like a different thing. Now let's say, let's understand the concept from here. From this church, this is the youth group. Okay. Now let's say this is the youth group and you want another senior group here. There is another room and you want to keep senior group here, senior citizen. So what we choose here, the lower frequency filter, we will choose, I'm talking about filter like that language, okay? Lower frequency filter like the youngest one, we will choose 50 because this is senior. and higher, we will choose like what? We can say 100 or even more than 100 years old people want to come, they can come. We can say 120, and that includes everybody from 50 to 120. So, and then another group, kids group, right? Another group is like a children's group. Okay, the children's group, like there's a children's group also have like different, like toddlers, youth group, or there's a adolescents group, the different group. Like let's say this toddler group. So we say 6 month, 6 month to 2 years old. We want the very this is toddler group, so that we are just taking care of the babysitting only. Okay, now I want to know, do you understand this concept? Do you understand like what I'm talking about? Yeah. Do you understand how we are categorizing? Yeah. So you understand we have to choose lower and higher to make a group, all kind of group. Okay? Like this is uh-huh.
Choose. How can we find out the low or high?
Yeah, that how can we find out? That's a good question. Like how can you find out people in the church? Because everybody in the church, right? And you go announce, hey, room number 1 is for senior group. So 50 years old to 120, go over there. Room number 2, there's a toddler, kids group, 6 months to 2 years old. Please go to room number 2. Room number 3 is youth group. From 16 to 22, go to room number 3. Room number 4, adult group. From 23 to 49, go over there. So you made it 4 different groups. Okay. Now, if we discuss about polysomnography language, then what we do is like we make a group here also. The first group we make EEG group. Okay, guys, EEG, all EEG, go to room number 1. So what? And they say, okay, all EEG are looking at you. Okay, am I EEG or not? Then unless you tell them lower and higher, they don't understand, right? Because this is what it looks like. Look, this is what electricity is forming the signal, like our brain is making this signal. This signal has all kind of wave, 0.00001 hertz and to 1000 hertz. Everything is over here. But now we have to choose for the EEG, what is EEG? So the EEG, it says like, okay, now lower frequency filter for EEG is 0.3 hertz. Okay, 0.3 hertz. So less than 0.3, they are not going to enter. If there's a 0.2 hertz frequency is blocked now, they will not enter in that EEG channel. And then what is the highest one? So highest frequency filter. You have to give them the highest frequency filter. So check it out, what will be highest frequency filter. Now here is the thing, highest frequency filter is here, 35. For EEG, 35. Okay, highest frequency filter is 35. Now we blocked for EEG, room number 1, EEG, the lowest is 0.3 hertz, highest is 35 hertz. If you are 40 hertz, don't go over there. Okay, if you are 60 hertz, don't go over there. So 60 hertz higher frequency filter is an artifact, so we are blocking them. We are not allowing to go to that EEG channel. Now we go like, okay, now room number 2, that's the EOG, electrooculogram for the eyes. Now from the same group of whole thing, you're gonna tell them, okay, what will be for the EOG? It's the same thing. Like for EOG, you will say, here it says like a little bit different. It says like 0.1 for EOG channel, but like BRPT standard, it says the same thing. For EOG, lower frequency filter is 0.3. That's the same, 0.3 Hertz. And highest frequency filter is 35. Okay, room number 2. So it's the same. That means EEG and EMG, same people, same waves will go both room number 1, room number 2. They choose where to go, or they go to both rooms, no problem. Now we come EMG channel. EMG channel. EMG is like this. Look, EMG has big movement. This much big, from this position to this position. So movement is this big. If the wire is here, movement, there is no movement, very little movement. It only making some signals like that. But here in the leg wire, EMG means leg wire also, big movement, right? So for the EMG, the lowest one will be, look, 10 Hertz. The lowest frequency filter is a very big compared to the other one, 10 Hertz, right? In EMG, the lowest one is 10 Hertz. And what will be the highest one? Highest one will be 100. Look, so highest frequency filter will be 100. Okay, now this is very important. This is going to come on your test exam. They will ask you like what will be the lowest frequency filter and highest frequency filter, and you need to know like for EMG, EOG and ECG, there's a different channels. And okay, now we are going to study about another thing. Do you have any question about filter? Frequency filter.
So this frequency is based on wave, right?
Yeah. Frequency means is for the wave, right?
Yeah.
Frequency filter, yes.
So
Yeah, because you're thinking now, what is this, right? What is this? What we are talking about? You need some kind of maybe example, and I'll show you the example. No worries.
okay.
So I'm going to show you the real waves now, and from that real waves, you will understand what is the what we're talking about. Okay. Let's check this one. Okay. Check it out. These are the channels, right? F3, M2, F4, C3, M2, C4, C4, M1, O1, M2, O2, M1. This is EOG channel, LEOG. This is EOG channel, left and right. Now, you see these are the waves. And we are, I was just wondering what happens if we don't. Let's check it out. These are the signals. You see high pass filter. See the filter here? Okay. Filters. Look. High pass, low pass. High pass means what is the highest frequency you wanted to let in. So what do we do? High pass means lower frequency filter. So what we do here, 0.3. We will put here like 0.3. This is what we want. And in here we want 35. Okay, and this is for what channel? Signal. Look, this is for, I'm trying to do like this one. Now check it out what happens. See, it becomes so nice, right? It becomes clean. But if okay, now let's go to channel property, and again signal content. If I don't choose this one, and we did not select any, so this looks like, it still looks, it has, this is the rough one, this is rough. But I can show you like what happens if like let's say we choose this way, signal, okay, what we want now, let's say we want here 35 or 100 hertz high frequency, and we want here 200. Let's check what happens. Look, it says no, you cannot do that, because low pass, it says low pass frequency must be number 0 to 100. Okay, so I'll put it here, any number, 99. All right, look what happened. It become like a straight line. Why is that? Because this F3, F4, all of these rooms have very high frequency waves are going, so that means like it turned into a straight line, and we don't need those. We cannot read now. We cannot see any alpha, we cannot see any beta or theta, delta, we can't see anything. So what we need to do is like, we need to select. We have to tell them like, okay, for EEG, this is for EEG. So what do we say? Okay, this is the highest high frequency filter. What is high frequency filter for? What is high frequency filter for EEG?
35.
What is high frequency filter for 35, right? And what is the lowest one?
0.1.
Yeah, 0.3. Okay, 0.3. Okay, so high pass means lower frequency filter. So I put like 0.3, and now this one for this one is highest frequency filter. What is the highest frequency filter? 35. And I will say okay. Look, I did it only for F3 channel. Now F3 channel look good. In F3 channel we can see alpha, delta, right? But in other F4 channel we still see straight line. So right click, let me go to F4 channel, and we will put like, look, we will change it, lower frequency filter. We are working on F4 channel. See here, F4 M1. So what do we do? High pass means lower frequency filter, which is 0.3, and this means lower frequency filter means high frequency filter. Low pass means highest frequency filter, and then 35. This is 35. And then I say okay, and check it out. What happens to this? Because we are working on right now F4 M1, right? Okay, now see, F4 M1 is looking good too. Okay, now C3 is not looking good because this is the whole church. Everyone is here. That's why it's so crowded and it becomes a straight line. We don't want that. In this channel, this room, suppose this room, this is youth group, toddler group. What we want is like we want the lowest one and highest one. The highest one, high pass, that's the lowest frequency filter. We want only 0.3. And the highest one we want only 35. And we say okay. Then we find good one now. Our selection is good. So same way like this one too. Channel property, I go signal content, high pass, which is lower frequency filter, 0.3. And this one is 35. I go like okay. This become nice too. Now O1, O2. These are easy also. So I change this one too. Signal highest is like 50. No, I don't want 50. I want 0.3. And for highest I want only 35. And I click OK. Now it is changed. And now O2 is also a straight line. So I don't want a straight line. I want my group. So my group is 0.3 and this is 35. And I say OK. And it changes to good one. Now in this channel, all of this channel, we can see alpha, delta, everything, right? Now EMG channel, this is EMG channel. Check this one out. Okay, in EMG channel, check it out. This is high and low pass. High pass means lower frequency filter. Let us check it to let's put like 0.3. Okay. Which channel is this?
EMG.
EMG. And you know what is the settings supposed to be? This is EMG. Look, this EMG channel. 1, 2, 3 EMG channels are there, and I'm just working on like chin EMG, and what is the frequency filter? Lowest frequency filter for EMG. 10. But you know, by mistake I put like 0.3. Okay. This is 0.3 is for the ECG, EEG, right? Like let's put for EEG, and what is the highest? And highest is 100, but I put like only 35 by mistake. I made a mistake. I put it like EEG. So what happens? Now here you will see EMG channel. You will see no activity here. You will see no activity. Okay. All right. So, okay, let's go change it. I put it this and it made like it's okay. It did not do that big change. So the highest frequency, that's the high pass means low frequency filter, supposed to be 10. This is supposed to be 100. And then press OK. Look what happens to chin. It gives some good clean wave here. And leg EMG is the same way. You can control what kind of wave you want to pass. Like a high pass, the lowest frequency filter. You say like okay, 0.5. And highest I don't want to make like high. I will do like 0.3. Check it out what happens for leg wire. Look, It did not give any kind of signal. Just the straight line, very thin straight line, no activity you can see. So using or not using is same, it's not different. Okay, so you're supposed to put it like 10 here, 35 here, and then you will get the wave, and that wave is good for leg Y. So all this channel, this is EMG channel, 3 EMG channel, we have frequency filter, lowest and highest. For this EEG channel, we have lowest and highest frequency filter. I try to give you concept from church and group, different group number 1, 2, 3, 4. And if we choose frequency filter, like in your youth group, you told me like 16 to 22. But if you put youth group 50 to 100, and that all the senior people will go over there, will that become your youth group? No. Because you still see people. You still see people in that room. But that room is not youth. That is senior. That become different group. So same way, waves has their frequency. So what kind of wave you wanted to see? So in EEG, you will call EEG wave when their highest and lowest is like 0.3, highest is 35. That are whatever waves you will see over there, and that will be EEG, and that wave and looks like this one. This is EEG. And when you set up like EMG, lowest is 10, highest is 100, that is EMG. Okay? Now, maybe when we see people, our mind works. But when we go to wave, everything looks same or straight line, and we cannot recognize. We need to work, practice more and more and more. Then we will understand what is this. All right. But like, let's say you are having sleep study. You are doing sleep study, and your waves look like this. Okay, let me show you. Your wave look like this. And by mistake, for all EEG, you set up like EMG channel, and your wave look like this. It still look okay. Like for EEG, you put 100 and 100. What does this mean? Okay. Let's say 0.3, 0.3. Let's see what happened. I'm just playing with it. Look. Now your waves are like this. And you are running sleep study. Is this good?
No.
This is no good. And you are sleep tech. Yeah, you are a sleep technologist. And you are running your sleep study like this straight line. That means you don't know what you are doing. Because you have to have like this kind of EEG. You see EOG channel. You can see like some alpha, beta. So it should be like that too. So what we do, we right click, go to channel setting, go to signal, and because here's the correct setting is not given. Like you have to put it like highest frequency filter is supposed to be 35. And now, I forgot, I did only one. Now let me do all the channel. So let's go to signal, this 35, and you see here, apply to all channels. So I click this one and click OK. So now you can see alpha waves, theta waves. Yeah. So this is what you see now. And when you're running sleep study like this, then you're good. You're doing good. But if you don't know, if you don't know, if you everything going straight line and you're looking and what you're doing, I'm doing sleep study. This is not sleep study. You don't know what you're doing. So everything, I have seen those kind of student too. They're looking way, and I ask them, what are you doing? They say, I'm doing sleep study. I did hookup and running sleep study. And I go like, you see, everything is going straight line. And I don't know. I hook up, I did everything, but I don't know. It is going straight line. That means if it is going straight line, that means something is wrong. You need to figure out something. And what is wrong? That means filter is wrong. Filter setting is wrong. So go to filter, set up highest frequency filter 0.3. Sorry, highest frequency filter 35. Lowest one is 0.3. So when you set up that and click OK, then it comes everything alpha, beta, theta. So that's how we are choosing from the whole. Our brain makes all kind of way, and we have to choose from there. Okay, I hope
So
you
I
understood.
think
Mhm.
when we before we start sleep study, it is necessary to check uh, settings too.
Yes, if you are in the first time you went to the sleep lab, you don't know your settings are. So normally what happens is you can save it. You set it, save it. And when you save it, then you can every time you open your system, it already saved it like that. Okay? So it's easy. You don't have to do all the time filter setting. Only for one time, and then it will, and that is called workspace. So workspace, let me tell you, you can save it as a workspace. Look, this is called workspace. You see here,
I can see.
workspace, right? Oh yeah, just a second. You see workspace? In the top right here, you see tools. Yeah, tools, video tools, and workspace.
Oh, workspace.
Yeah, workspace. And in the workspace, you see raw data. Raw data means it is collecting everything. And then you go down, and I made it like SAM PSD. I save it my own channel here. Look, because, okay, I save it like workspace. I put it like, what is this? SAM PSD. Okay. Still, okay. Can you see this one now? SAM CPAP, SAM PSD.
Yeah.
So what I do, if I click SAM PSD, then look how clean it is. It looks so clean, right? It is so clean. But if I check raw data, it is dark. It's not very clean. It is dark waves. But if I change it to my workspace, my montage, then it becomes so clean, nice. I did it for myself because, like, when I go to work, I save it. I set up all the frequencies, everything correctly, and save it in my name. So when I run the sleep study, I choose my montage. That's called montage. So I choose my montage and run the sleep study, and I see everything clean. And so in that way, mainly everything comes clean when we have correct filter setting. Okay. Now the next thing we will see, this we just learned about filter setting. Now we are going to see another thing now. Okay, check it out. This is, now we're going to see about Now next thing is we're going to see the sensitivity. What is sensitivity? And what is gain? What is sensitivity? What is gain? Okay, these two things. Sensitivity. Now to understand sensitivity, sensitive, you understand what is sensitive means. Yeah, some people are very sensitive. If you tell them like go over there, they may cry. Very sensitive. Some maybe not. You tell them whatever, but they don't care. So the waves are like that too. So we understand the sensitivity of the wave. And if the waves are going like this, so sensitivity and gain, what it does is like filter the difference between filter and sensitivity. Filter change the frequency, right? Because we can lower and higher frequency we can set up for EEG, EMG, EOG. So filters, when we set up the filter, it gives us some kind of channel. It gives us rooms, youth group, adult group, like those filters. But sensitivity, it just does like big and small. All right, let me show you this one. Look here, you can see this letter is big, but what I can do is like make it small. Can you see now? This is so small, right?
Yeah.
See, so small. And now I can change it to big. I can make it big like this. I can even make it big like this. Sensitivity. So am I changing the letters instead? Am I changing the frequency? No, I'm just changing the size of this word. I'm not changing the word, I'm changing the size of the word. Okay? The picture, we can make it big or small, but this is same thing. So sensitivity, what it does is it makes bigger or smaller. Gain also makes smaller or bigger. It does not change the frequency, it does not change the type of waves, but it only changes the size. Like here, you can see clearly, but if I make it smaller, then it will be difficult. So I put it like certain size. Okay, so sensitivity and gain changes the size. Okay, you see, controls the amplitude. That is called amplitude. Amplitude means the size, height of these things. So, and it is measured micro per is a millimeter per millimeter. So what will be the per millimeter of our thing? Like let's check it out. Okay. So it depends, like different system has different. Some system like sleep system, look at this. To change the sensitivity, what I do, I put the cursor in F3, right? I have this cursor is in F3, then I increase the size, or I do this. I have to find out channel. Let's see if there is a height here. That's called scaling. Okay, height. I was in this one, right? F3 channel. So I will make it bigger. Like let's say I will make it like 50. the channel 50, and check it out what happens. Look, I increase the sensitivity. I increase the sensitivity of EEG channel. Alright, so I put it sensitivity is 50. Sensitivity means pressing, like how can we understand is like pressing. Sensitivity means pressing, okay? Like this big, this bottle is big, but if I press, it becomes smaller. That is sensitivity, okay? When you make the sensitivity big, if you give a big pressure, the wave becomes smaller. When make a small, and then it becomes big. The waves are like, if you put your sensitivity low, look, I put it 50, the wave became like almost a straight line. So I put it like 1. If I put it like 1, then that means sensitivity is very low. The wave can go bigger. Look, wave becomes so big. Did you see the difference?
So sensitivity also kind of setting to make the wave readable.
Yes, increasing the size of the wave.
This is all about setting.
Yeah, this is all we are talking about settings, right? We are studying about settings, how to set up the wave. So first we studied about filter setting. Filter will change the frequency of the wave, right? Look, this is the frequency, but this is so big we cannot read. If you, in the EOG it is good size, we can read, but in F3 is so big we cannot read. So if the sensitivity is no correct sensitivity, then we cannot read it. So what is the correct sensitivity? The filter setting of this wave is correct. Filter setting is 0.3 minimum. Lower frequency filter is 0.3. Highest frequency filter is 35 on this one, which is correct. But sensitivity is very low. We have to press, make the bigger press so that the height of the wave will be smaller. Okay, let me change it, okay? So what is the correct sensitivity? Correct sensitivity is 7, okay?
So what is the sign of this volume?
Which one?
It is like 7 millimeter
Yeah, 7 microvolt.
or microvolt.
Yeah, that's called microvolt. 7 microvolt per mm per millimeter. That's a 7, yeah. So when we put it like 7, okay, let's see what happens. Now this is 50. Oh, sorry, this is 1. I'm going to change it to 7, okay? Because the sensitivity, yeah, look, this is called scaling, okay? What I'm going to do is like I put it 7. Good. And I will put it okay. Look. When I put like sensitivity 7, everything corrected. Everything looks good. So sensitivity, what it does is like it gives the size of the wave. Gain is same thing. Gain and sensitivity are opposite. When we increase the sensitivity, sensitivity means pressing. Sensitivity means pressing. Gain means pulling. Okay? So sensitivity means pressing. Like if you press more, the wave becomes smaller. If your sensitivity is 50, your wave is going to be small because sensitivity is too big. But if your gain is big, your waves goes big. If your gain is low, your waves become smaller. Why we are studying about sensitivity and gain is because some system is set up like gain, and some system has been set up like sensitivity. Look, sensitivity and gain. So what it controls the amplitude, it controls the amplification signal. That's the same thing. Okay, so when you increase the sensitivity, what is the height of the wave? Decreases or increases?
Can you repeat it?
Okay, what is sensitivity? Pressing.
Pressings.
Okay, what is gain?
Make
Pulling.
yeah, pulling.
Okay, height. We are talking about height of the wave. Sensitivity means pressing. Okay, and gain means pulling.
Pulling.
So if you increase the gain, height of the wave, what will be? What happens? Increase or decrease?
Decrease.
Yeah, just understand. Like sensitivity means pressing.
Press.
Look, this is wave, and I'm pressing like with 7. Now 7 is looking good bottle, but if I press like 50, this bottle becomes so small I cannot see this is bottle. So sensitivity, more sensitivity, 50 is making is small. Okay, but like gain, if I make gain like 7, then it becomes like gain is 7 means very small. If I increase the gain to make it big, I have to increase the gain. Gain is like this. This is gain 7. Okay, gain, if I increase the gain, height increases. If I increase the sensitivity, height decreases. Opposite. Okay, so if I increase the sensitivity, height becomes small because I'm pressing. If I increase the gain, because I'm pulling, so height becomes bigger. Makes sense or not?
Yeah.
If I increase the sensitivity, what happens to the height? Amplitude. Decrease or increase?
When we increase the sensitivity
Sensitivity?
and decrease the height.
Decrease. It decreases the height. Amplitude. Okay, amplitude lowers or decreases. But when I increase the gain, the height will be increase. Right? So it works opposite. So why we have to study about sensitivity and gain? Because only one thing would work. Why we have to study gain also and sensitivity also? Because there's the sleep software. Okay, the sleep software are different. This software that we are talking about, this is Alice. This is called G3 software. The name of this software is called Alice G3, and this one is developed by Respironics. But there is another company, there's another company called Biologic or Exceltech. They create same kind of software to do the sleep study, but that's different. They set up like not sensitivity but gain. So when that computer is gain, it has gain, then we have to increase to make it big, decrease to make it small. But this one system is like set up on the sensitivity. So we have to, if we want to decrease the height, we have to increase the sensitivity. If we want to increase the height, we have to decrease the sensitivity. Make sense or not? Why do we have to study both sensitivity and
then we will use that kinds of software.
yes, very good. Different sleep lab uses different types of sleep study software. Some sleep study software are set up sensitivity, and some sleep study softwares are set up on gain. That's why there's a different types of, we need to learn both. Now you learned about sensitivity and you went to the software where there's gain only, there's no sensitivity, then you're trying to do something, is not working. That's why we need to understand, okay? And what gain or sensitivity does, it increases or decreases the amplitude of the wave. What filter does, it changes the shape and size. Okay. Look, let me tell you about shape and size. What is the difference between shape and size? This is A. This is A. Are they same or different?
Size.
Only size is different, right?
It's the same.
Shape is same. Same, different. Very good. Shape is same, size is different. This is A, so you understand. Like let's say this is alpha wave. Alpha wave. This is alpha. Okay? Now I'm making it small. This is also alpha. So what does this mean? Size is different, shape is same, right? But now this is alpha and this is theta. This is 60 Hz artifact. See? Are they same?
No.
No. This is alpha, this is 60 Hz wave. Different. This alpha is 8 to 13. So these two are different. So what happens? Filter. When we change the filter, it makes different waves. Not even same. It is a different wave. Alpha can be 60 Hz artifact. Alpha can be delta. Alpha can be spindles. Okay? But like if we change this sensitivity, or gain of this wave, this become big. We can make it big or we can make it even small. But this is alpha. This is alpha. So sensitivity normally same. It does not change waves. It only changes the size. But filter, if we change the filter, it changes from one wave to another wave. It can make any other wave. Alpha can be 60 Hz, alpha can be like spindle, alpha can go delta. Okay, makes sense? So filter, we have filter and we have sensitivity or gain. Okay, when we change filter, changes the type of the wave, right? It changes the type of the wave. And when we change the sensitivity and gain, it changes the shape of the wave. Okay. Did you understand this thing?
Yeah.
Okay, so that's why these two are different. Okay, now so but these two are work differently. Increasing sensitivity decreases the amplitude, increasing the gain increases the amplitude, right? Okay, all right, so we did about sensitivity too. Now let's talk about this thing, the practical troubleshooting. Flat signal like a straight line, normally that becomes a very common problem. Okay, this flat screen means becomes a straight line, and we saw that before. So and then over amplitude sometimes becomes very high amplitude, sometimes disappearing the wave, sometimes the wave disappear. All this becomes because of changing the filter or sensitivity, and we have to adjust it. We can adjust it by adjusting the filter and sensitivity or gain. Okay, so if the problem comes like scenario practice, when we practice, when the signal is drifting, going everywhere, what do? Waveforms are too small. So what are the setting? What settings do you change? If the if if your signal is like a small line, very small, you want to increase the shape of the channel. What will you increase?
So shape of the channel
Uh-huh.
is we need to use sensitivity.
Yeah, to change the shape of the channel, you have to change the sensitivity, right?
Yeah.
So good. So if you want to change the different types of wave, then you have to change the filter.
Yes.
Okay. So this is it. And you can check the, like there is PowerPoint. We did not go with the PowerPoint today, but you can go from the PowerPoint also. Check it out. Look, understanding PSC, sensitivity, and this one. Okay. Objectives. What are the objectives? This is the same thing. It impact the accuracy, essential the proper signal flow, signal pathway from the patient to screen, analog to digital, like this one. Filters, lower frequency filter, remove slow drifting, higher frequency filter, removes fast artifact, and example EEG, lowest frequency filter, EOG and EMG. Look, EEG, this is EEG, highest frequency filter is like this. EMG, the highest frequency filter is supposed to be 100. Sensitivity explain. Controls signal amplitude. Sensitivity controls, look, how big or small signal appears on the screen based on how many microvolt of signal equal to 1 millimeter of display height. The sensitivity is called like microvolt by per millimeter. So controls signal amplitude, height. Effects waveform size. Sensitivity changes the size. So standard setting EEG is 7, EOG is 10, EMG is 1. Check this one out. Comparison to 0.4 microvolt and 0.9 microvolt. Look, when we put 0.4 microvolt, this wave looks smaller. When we put like 0.9 microvolt of gain, it becomes bigger. Okay, So high frequency filter, flat looking wave, that means makes it smaller. Low frequency filter makes bigger. Okay, gain. What is gain? Gain controls how visually amplified a signal appears after it's already been recorded. That means increases or decreases the size, amplifies the signal electronically, used post recording displayed. I mean, this language makes a little bit different, but like we already know that. So gain and versus sensitivity. Effects: sensitivity, waveform size. Gain displays brightness. Okay, I don't want you to do this one. Anyway, look at this problem. EEG signal is barely visible, very small. So what settings do you adjust?
EEG filter.
Yeah. It says visible. Visible. You cannot see the, barely visible means you're not able to see the settings. You are not able to see the signal. That means you have to change the frequency. You see, like here, not the frequency but sensitivity. Because your sensitivity is high, then you cannot see the signal, right? If your sensitivity is low, your signal will be too big. So what you need to do, put a exact standard settings of sensitivity.
7.
Visible means you cannot see. Okay. So you need to practice these questions, because even though you understand, like if you don't understand the language, then it will be difficult. Okay. Now let's check one more time. Okay, here. Okay, here. I'm going to change that questionnaire. Now I'm going to change the sensitivity. Okay. I will press it. Sensitivity means pressing, right? If I press with 50 microvolt energy, check it out what happens. I'm going to apply all the signal. Look, it's barely visible. You cannot see it. So this is the question was asking. You barely see the signal. So in this case, what you need to do, you need to change the sensitivity. So I'm going to change the sensitivity like this one to 7, standard one. Then what happens? Look, I can see now. Okay, that was the question. Yeah, check this question. So you need to understand the question. It says like a signal is barely visible. It's not visible. It's so small. So it's asking what settings do you need to adjust. A is high frequency filter, sensitivity, gain, or montage. And you need to say sensitivity or gain. So here is an example. Let's say EEG channel was recorded with sensitivity, then your answer will be 7, sensitivity, standard, right? And if it is set up as a gain, your system is set up in gain, then you have to change the gain. So the answer is B or C. Okay? To change the shape, you need to change the sensitivity or gain. So this is the chapter